over the next several class periods, we will be working with something called the properties of exponents. Properties of exponents. There are a total of 7 properties of exponents that we will be talking about. We will not cover all 7 of them today, but it would be good to start a list that has 7 spots. We'll fill in 3 of them today, and then a couple of them each day for the next couple class periods. So properties of exponents, give yourself a list, 7 spots. The first property of exponents we're going to talk about says a to the m times a to the n. That's a giant times sign. I don't know what happened there, but a to the m times a to the n. So notice I have exponents here. Notice also the thing I'm raising to the exponent, in this case a, is the same for each. So if I have 2 things, they have the same base, and I'm multiplying. That's something that might look like this. Let's go a to the 5th times a to the 3rd. A to the 5th, remember, is a times a 5 times. There's a to the 5th, and a to the 3rd would be a times a times a. I could rewrite this. I have 1, 2, 3, 4, 5, 6, 7, 8. I'm multiplying a by itself 8 times. The question is, how can I go from here to here without doing that middle step every single time? And hopefully we can recognize that I would add up these exponents. 5 plus 3 gives us 8. So a to the m times a to the n is a to the m plus n. If I multiply 2 things that have the same base, I will add their exponents. The next one is actually the 3rd one here. This is the next one that we'll be talking about. It says a to the m to the n. This is called the power of a power property. Power of a power. And this is something like a squared to the 5th. A squared to the 5th. So to the 5th means multiply this by itself 5 times. A squared times a squared times a squared 5 times. And once we have this first property, we know if I multiply things, I add up their exponents. 2 plus 2 is 4, plus 2 is 6, plus 2 is 8, plus 2 is 10. And then the same question comes up, how do I go from here to here without doing that middle step? Power of a power, I'm going to multiply the exponents. So if I have power of a power, we multiply exponents. A to the m times n. A to the mn power. If I multiply, I add the exponents. If I have a power of a power, I multiply the exponents. One more property we're doing today, and it is number 5 here. It says if I have a quantity where I'm multiplying in there and raise it to an exponent, it'd be like AB to the 3rd. That'd be AB times AB times AB. And I'm allowed to multiply in any order I want. Multiplication is commutative. A times A times A is A cubed. And B times B times B is B cubed. Notice if I'm multiplying in here inside the parentheses and raise it to an exponent, I can distribute that exponent. I can do A to the n times B to the n. This is called the power of a product rule. So if I'm multiplying, I add the exponents. Power of a power, we multiply the exponents. If I have a product, and then raise that to a power, I can distribute the power. And let's take a look at a few examples here. We are asked all the directions on these. We are asked to completely simplify the expression. Number 1 says a to the 5th times a to the 2nd. A to the 5th times a to the 2nd. Looking at the three properties we just looked at, which one of these applies? A to the 5th times a to the 2nd. It's this one here. A to the 5th times a to the 2nd. If I multiply, I want to add the exponents. I just add my exponents. 5 plus 2 is 7. Notice the base stays the same. It's just a. A to the 5 plus 2. A to the 7th. Even if the a was a number, if it was like 2 to the 5th times 2 to the 2nd, we add the exponents. The base stays the same. It would be 2 to the 7th in that case. Number 2 says b to the 6th times b to the 2nd. B to the 6th times b to the 2nd. Everything I'm doing in here is multiplication. When that's the case, I add up the exponents. 6 plus, it's understood to be a 1, is 7 plus 2. It's 9. B to the 9th. Same directions. Number 3 says c to the 4th d times c to the 2nd d to the 11th. C to the 4th d times c squared d to the 11th. Remember, in order to add up the exponents, we said we have to have the same base. A and A need to be the same. So when I'm doing this one, I'm doing c to the 4th times c to the 2nd. I add the exponents when I multiply. 4 plus 2 is 6. C is to the 6th. And then the d's, I'm multiplying. So I add up those exponents as well. 1 plus 11 is 12. C to the 6th, d to the 12th. These two do not have the same base, so I cannot add the 6 and the 12. I just leave it as c to the 6th, d to the 12th. The base of the exponent is not the same. Number 4 says e cubed to the 4th. E cubed to the 4th. Notice here I have a power that I'm raising to another power. E to the 3rd to the 4th. Looking back at our list, it does not look like this first one that we've been using. It looks like this one here. Power of a power property. When that's the case, I multiply the exponents. E to the 3rd to the 4th, I do 3 times 4 is 12. It is e to the 12th. Number 5, f squared to the 11th power. F squared to the 11th power. Again, we've got a power of a power. When that's the case, we multiply the exponents. 2 times 11. F to the 22nd. Number 6. Number Number 6 has a parenthesis. Inside the parenthesis, we've got g cubed times g to the 4th, and then we're raising that all to the 3rd power. G cubed times g to the 4th, all to the 3rd. Let's start inside the parentheses. Don't worry about this part yet. Inside the parentheses, I've got g cubed times g to the 4th. And that looks a lot like those first couple we did. When I multiply, what am I doing to the exponents? I'm adding the exponents. 3 plus 4 is 7. That's g to the 7th. So I simplified this here, and then I'm going to copy the rest of it. Parentheses to the 3rd. And now it looks a lot like number 5. Power of a power. We multiply the exponents. 7 times 3, g to the 21st. Property number 7. Inside parentheses, I've got h squared, j to the 4th, all to the 5th. H squared, j to the 4th, all to the 5th power. Because my bases are not the same inside the parentheses, I cannot add these like I did on the previous one. This is the one where I have two things that do not have the same base. When that's the case, I distribute this exponent. I raise each thing to this same exponent. Notice I have a product. I'm multiplying to an exponent. I can distribute the to the 5th. So I've got h squared to the 5th. And then I've got j to the 4th to the 5th. I raised each of these things to the 5th power. Now this is power of a power. I multiply. Power of a power, I multiply. H to the 10th, j to the 20th. Going back to the previous example, I could have done this one that same way. We could have done j to the 3rd to the 3rd. That's a g, sorry. Times j to the 4th to the 3rd. Distributed this. Power of a power, we multiply. 4 times 3 is 12. Now, when we multiply, now we add. 9 and 12 make 21. Either way, I get the same answer. I think it's easier if we do it the way that we initially did, but we could do it either way. Number 8. Number 8 looks kind of similar. The k to the 4th is actually the same as j to the 4th. But I've got this number out front. I've got 3k to the 4th all to the 3rd. 3k to the 4th all to the 3rd power. I do it the same way. I distribute this 3. So I have 3 to the 3rd times k to the 4th to the 3rd. I raise each part to the 3rd power. The 3 is not connected to the k. The k is to the 4th, but the 3 is not. So I do treat them separately. This part here, we do the same as over here. 4 times 3 is 12. 3 to the 3rd means 3 times 3 times 3. 3 times 3 is 9. Times 3 is 27. 27k to the 12th. These are our last two, numbers 9 and 10. L to the 6th times L cubed all to the 7th. L to the 6th times L cubed all to the 7th. I would recognize that right here I have power of a power. Power of a power, what do we do with the exponents? We multiply them. 3 times 7 is 21. And this part I copy down. And then when I multiply, I add the exponents. 6 and 21 make 27. Last one. And it looks like a long one. 2m n to the fourth all squared times 3m cubed n. 2m n to the fourth all squared times 3m cubed n. Let's take it one piece at a time. I've got something to the second. Check inside the parentheses. These all have different bases, so I can't do anything there. I have this whole thing to the second. All I'm doing inside here is multiplying. When that's the case, I can distribute this to the second. So I need to raise each thing to the second. So I'm going to raise 2 to the second, m to the second, and n to the fourth to the second. I am distributing that to the second, to each of the things. I'm going to recopy this part here. 2 to the second, that means 2 times 2, it's 4. M to the second, I can't do anything with. N to the fourth to the second, power of a power. I want to multiply the exponents. And now I'm multiplying two things. 4 times 3 is 12. M squared times m to the third. When we multiply, we add up the exponents. 2 and 3 make 5. N to the eighth times n to the first. 8 and 1 make 9. 12m to the fifth, n to the ninth.